Okay, we'll go ahead and get started. Welcome, everyone. Thanks so much for joining the session. I'm Amanda Frederick. I am the Program Communications Manager with Women Who Code. And today I have the pleasure of introducing Manjiri Nandkumar Birajdar. And she is joining us all the way from India today. Or actually, are you in Germany now, Manjiri?
Yes, I'm in Germany.
Okay,
yes.
Wonderful. Manjiri is a student research assistant at the Technical University in Darmstadt, Germany. She's an accomplished software engineer with 8+ years of experience, including implementing research software prototypes. She is currently pursuing a full-time master's in distributed software systems at a technical university in Darmstadt, Germany. She specializes in blockchain technology and is currently an evangelist at the Women Who Code blockchain track. She is passionate about learning cutting-edge technology, implementing research software prototypes, and empowering women to pursue careers in technology. So today she'll be sharing with us blockchain deep development using Python and Web3.py, which you joined the session. So Manjiri, welcome to the stage.
Yeah, thank you. Thank you, Amanda, for the wonderful introduction. So hello, everyone. Good morning, good afternoon, and good evening from wherever you are joining. Thank you for joining my talk. And today we are going to learn about blockchain DApp development using Python. So today at end of the session, you will have understanding of what is Web 2.0, Web 3.0, then what is blockchain, how it works, and the difference between app and DApp, and how the Python tools for the blockchains are, and lastly, you will get to see the code of the DApp for the Ethereum blockchain. So let's get started. Yeah, so just I always loved the good analogy as a way of explaining technical concepts to understand it to the all audience. So let me start with like two blockchain analogies. So the first one is the football game. So I hope everybody is like familiar with the word. So how does it work? So how does each player knows what the score in the football game is at any time, and no one can change the score without convincing everyone playing the football. So on the playground of the football game, there is no referee, so there is no centralized authority which is controlling the game. So how the game is played successfully, so the basics is everyone knows the rule, they play by the rules, and because of that we call it a game of football, right? Otherwise there is no playing football game. So when the kid fouls in some way, then there is going to be like a decision has to be made, right? So people so the kids gather and they act upon this foul and or simply get to continue the game. So this is how the consensus is achieved between the kids. Then if we consider the ledger part, so ledger is like everybody's keeping score in their heads. So every kid doesn't actually need to see each goal being scored as long as all of them agree on this current score is. So nobody can change. So this score is immutable because single kid cannot change the score without convincing majority of the kids, right? So this is how one analogy works. Then the second one is like really simple. I think everybody knows Google Docs. So when we create a document and share it with a group of people, right? So the document is actually distributed instead of it's like copied or transferred to anyone. So this creates a decentralized distribution chain that gives everyone access to the document. So you can see on the right side that who is making what changes. So this gives the facility like no one is logged out awaiting the changes from like making another party, or while all the modifications to the doc are being recorded in the real time and everybody is making the changes and it's completely transparent to everyone. Yeah, so I hope you got some good way of understanding how the blockchain looks like and why is it there. So some high level understanding. Of course, I mean blockchain is more complicated than just a simple Google Doc, but Yeah, so let's see some technical perspectives. So everybody is aware of the current payment system and how it works. So the ledger is by definition is like a book of records. So where all the financial transactions of the organizations are kept. So take any banking organization. And for schools and colleges, for example, if you see, it's called register. So in the image above, you can see on the left hand side, it's called centralized ledger. So the popular example, like I said, is the payment system. So bank as a centralized system has a total control over these transactions are posted on the ledger, right? So bank is controlling everything. So meaning it's a centralized asset ledger which list all the transactions that are controlled in by a single entity. That is a banking term. It's called bank statements. I think every one of you have a bank account and you see the bank statements, right? So for the bank, it's like a single ledger. So so we are discussing blockchain now. So which is an example of a distributed ledger in contradicting to the centralized ledger. So a distributed ledger is essentially an asset database that can be shared across the network of multiple nodes, then geographies or multiple institutes. And each participant in the network has copy of this ledger. So any changes in this ledger are reflected in all the copies in the network. So this is how the ledger scenario works. So now let me jump into the introduction of the blockchain in the technical perspective. So what is blockchain? So everyone, I hope everyone heard of the word database. So blockchain is a type of database with following properties. So the first one is the information on the blockchain network is not controlled by a centralized authority. So the participants of the network maintain the data and they hold the democratic authority to approve any transaction which can happen on the blockchain network. So specifically, I'm talking about the public networks because there is another concept of private networks too. So if and the second property is if you are participant in the blockchain network, you will have the same copy of the ledger which all other participants have. So even if one node or the data on one particular participant computer gets corrupted, but the other participant will be alerted immediately and then they will rectify as soon possible. So in terms of blockchain, it's called consensus. So this is how it works. Then the last point I would like to say is about immutability. So data on this ledger is immutable, meaning once it's recorded on the block, no one can change it. So now we will see how this looks like, how the block in the blockchain looks like. So blockchain consists of chain of blocks, right? But how does the block look like? So here is in this image you can see chain of blocks. So each block you can see has a nonce, then it has a previous block hash. So it's like a chain. So each block has this and it also has list of transactions. So the transaction has more detailed structure. So on the above you can see like a sender who sent the transaction, then the receiver to whom we want to send the transaction, and the amount, how much money you want to send the transaction, and the hash of the transaction, which is the unique value to identify this transaction. And the rest of the fields are more relevant to transaction fees. So which itself is like another huge topic to discuss. So if you just see like what steps happens once we like send any transaction to the blockchain. So as soon as the transaction occurs, so each transaction is recorded in an indisputable transaction list, which we call ledger. So each peer has a copy of it. In the later stage, when the network reaches an agreement that is called consensus within the leaderless group, so leaderless group of peers, So this is how the steps goes, and at the final stage, the block is added to the network, to the ledger. So let's elaborate on how does the transaction get into the blockchain. Maybe with the illustration, you will get some more idea. So the new transaction, give me a second. Yeah, so the new transaction, when the new transaction enters into the network, the transaction is then broadcasted into the network, like in this peer-to-peer computers. So maybe they are present across the world. It's not like geographically present at only one position. So this network of computers then solve the problem, or they use some type of consensus mechanism to confirm the validity of this transaction. So itself, the consensus mechanism to speak about it's another topic. So just consider it as a black box where you give the transaction and it says if it's valid or not. So then once all the peers agree on if the transaction is valid, then the transaction is completed, and then it would be added to the list of transactions, and this list of transaction belongs to a block, and that block would be then added to the added to the the block is added to the blockchain. So yeah, then let's move on. So I hope you got some understanding of the basics of the blockchain. So the main question pops up, like why you want to learn blockchain. So with my perspective, I feel it's cutting edge technology, and this view of like global vision of having the infrastructure, right? When we look at the internet, so I really like that perspective. Then it brings more data security, and it also provides this concept of digital identity with a secure perspective. And definitely with my current engagements in the industry and with the Women Who Code, I can see how the blockchain technology is revolutionizing the range of industries. And definitely it's helpful to elevate your existing career. For example, if you are working as a like a business analyst in some financial company or any banks, then definitely the blockchain is one they are moving to. Okay, so next we will talk about how the whole web and this app development evolved. So I think most of you are interested in this part, like how this application development goes on. So if we talk about Web 1.0, Web 2.0, so in the Web 1.0, it was mostly read-only web. I'm not sure if everybody remembers it, but it was like just a static website and you just read from the website. And then came the Web 2.0, so where you have like social medias and where you read and write and post your blogs, and so it's more both features were included. So this is like how the transition has been. And then let's discuss a little bit more about Web 2.0 app development perspective. So as you can see on the left side of the image, so you have your browser and you connect to this web server. The web server has running the front end, back end, and the database, right? So for example, if you go on a website, click some button, so the HTTP request goes through the internet to this web server, and then the response is sent from this web server to the client, right? So this is how it has been working. So you can see the backend as one web server or cloud of the web server. So this is how it has been on the application development perspective. Then moving on to Web 3.0. So the new term pops up, which is DApp, decentralized application. So like in the traditional applications, so the decentralized applications also have front end, that we call client side. Then we have backend, so which is server side, and the user and the user interface for the DApp can be written in any language, so like a traditional application. So we can make calls to the backend. So here you can see in the image that the backend is what is changing. So how do the DApps differ from the traditional application? So like I said, the DApp has its backend code running on the decentralized peer-to-peer network, that is blockchain. So for example, you might have heard about BitTorrent, right, and Tor. So they are DApps that are running on pure peer-to-peer network, but it's not a blockchain. So but the concept, so then this blockchain DApp has its own backend code called smart contracts. I'll be explaining this in sooner slides. So that can be deployed on the blockchain, and it's most commonly the Ethereum blockchain. So the smart contract defines the logic for your entire DApp. So this is the more main important point, like writing a smart contract. Yeah, so I'm talking about the traditional front end and then connecting into the blockchain. So now comes the question, where can a Python developer take advantage of it? So then comes the point of Web3.py. We will discuss it soon. So before that, I would like to go through different aspect to develop this blockchain application on Ethereum. So today I'm gonna focus on only Ethereum part. So the first one is developing smart contract. So writing programs that run on the blockchain with the Solidity programming language. So there is a specific language which you need to learn. So I will brief you about the smart contract. It would be easier for you to understand. So then the second part is developing clients that talk to the blockchain. So you write your code that reads and writes data from the blockchain. So there might be a smart contract, there might not be a smart contract. So here comes the Web3.py, which enables you to fulfill the second responsibility, developing clients that talk to the blockchain. So we will see details in the next slide. So what is smart contract? So it is the fundamental building block of Ethereum application. So the smart contract is the one which digitalizes the agreement. For example, if you have a house and you are renting it from some company, so you make an agreement, right? You sign a contract. So like a digitalized version of the agreement. So by writing your terms into this agreement, into the computer code, basically, it's not like handwritten or something. So which will automatically execute when the contract terms are met. So with the simple metaphor for smart contract is a vending machine. So I think everybody has used the vending machines, and which work quite similar to smart contract, meaning specific input is guaranteed with predetermined output. So how does vending machine work? So it's like it is logically programmed, like before you're using it. So you select a product, then the vending machine returns the amount, specifically €1, €2, which depending on the product you're purchasing. And then you insert the correct amount, the coins or the cash. So then the vending machine verifies if you have inserted the correct amount or not. Then the machine dispenses the product of the choice. So this is how the smart contract also works. So the vending machine will only dispense your desired product after meeting all the requirements, right? So if you don't select a product and just insert money, so the vending machine won't give you the product, right? So like how vending machine removes the need for vendor employee, you are not like physically interacting with anybody. So smart contracts can replace the intermediaries in many industries. So this is how the smart contract is helpful. Then moving on to Web3.py. So Web3.py, in the image on the right side, you can see. So this is the the code which talks to the Ethereum blockchain. So as you can see in the image, you have your application and then you have your Ethereum network. So in between is the Web3.py. So Web3.py allows us to make requests to the individual Ethereum nodes on behalf of the entire network. And it is done using JSON RPC. So JSON RPC is basically globally identified protocol for remote procedure calling. So let's discuss about Web3.py. So it's like a collection of libraries that enables you to do following things like create an Ethereum smart contract, then read or write data to the smart contract, or you can just create smart contracts and much more. So let's look into how can we use this to talk to Ethereum using one simple diagram. So you can see here, like I said, using JSON RPC, it talks to the Ethereum blockchain. So as we learned in previous slides, that each node on the network gets a copy of all the code and the data on the network, right? So in order to connect to Ethereum node with JSON RPC on the blockchain network, we need to access to the Ethereum node. So without that node, we cannot get access to the blockchain, right? So we need to know that Ethereum node. So how do you set up your own, or or you use another service to talk to the network? So so if you want to set up your own Ethereum node, then you can use tools like Get, Parity, or just for the testing purpose, you can use Ganache. So, but this requires you to download a lot of data, and today's size is 273 GB of blockchain. So it's gonna take a lot of time, and you have to keep it synced with the main network. So this is a huge headache, right? So for the convenience, you can use Infura to access an Ethereum node. So you're not required to run anything yourself. So you can just write your application and you can use the Infura. So this is the service that provides you the remote Ethereum node for free. So if you want to quickly start your development, you can begin with that. So all you need is to sign up and obtain an API key and this URL, RPC URL, which will help you to connect to that node. So yeah, so there is another simpler way. So you have your own Ganache. You can install it on your machine, and you will get some accounts, and the balance in the account you can also interact with it. So the next is we talk about the DApp development. So here you can see, like we discussed, the client, browser, and then it's communicating to the blockchain using Web3. So the first step here is in the DApp development is deploying smart contract on the blockchain network. So like writing the code using Solidity itself is another learning task before getting into the smart contract. So the next step is, you can also use the existing smart contracts to try out yourself. So the second step is reading the data from this deployed smart contract. Then the third one is to send the transaction to this deployed smart contract. So this is how the 3 steps look like. So next we will see in short how to set up the environment. So the prerequisites for setting up the environment is you need Python. You can use the latest version, that's fine. Then you need Web3.py library, which you can install using pip install Web3. And last but not the least, the Ethereum node. So you can, to get started, you can use Ganache or Infura. So how much time is remaining? Okay, so let's see how to code. You can see, we will see in this checking account balance. then sending Ethereum transactions, and inspecting blocks with Web3.py. So here in the image, you can see an instance of Ganache. So this here you can see the list of accounts and the balance it has. So this is what I used for coding the following code. So I will explain you the three different parts. So the first important point is to include the Web3. So you have, once you have like PIP install Web3, then the first thing is to include this, import it. Then the Ganache URL where you are running your Ethereum node. So this is where you create your Web3 object, and this Web3 object is the most important one, which will help you to connect with the Ethereum node. So from there, using the JSON RPC, you're gonna speak with the Ethereum node. So the one example would be Web3 is connected. So once, so you have your Ethereum node up and running, but through the code, how you will know if it's running or not. So this Web3 dot is connected will help you to understand that. So it will return true or false. Then there will be mining going on in the blockchain. So how you will know which block is currently running. So which block is present right now. So with this web3.eth.block number, you will get the current block number. Then suppose you have your account through which you have deployed your smart contract. So you want to check the balance. For example, in the current payment system, you go in your account and click the balance, right? So like how much balance you have. So it's the similar one. So you will get the balance in Ether, which is the currency for Ethereum. So this is how you can check the balance. Then the next one is sending Ethereum transactions. First three are really important steps, like including the Web3, then connecting to your Ethereum node, and then is the most important. Then comes your remaining code. So now suppose you want to send some money to the other account. For example, in the current payment system, if you see, if you want to send in money to somebody, you need IBAN code, right? So with the IBAN, you can send the money to anybody. So similarly here in the Ethereum, you need an account number. So you need to log in into your own account. For that, you have wallets. This is like another concept, but specifically we use like wallets to transfer money from one account to another. So via coding, you can also do it. So using Python, so you get the account 1, account 2, and you need to fetch the addresses beforehand. Then you have private key for the sender's account. Then nonce is it's like counting at the transaction 1, 2, 3, so something similar. Then the most important point here is the transaction. So you have to write your own transaction. You have to build it based on the attributes. For example, nonce to is basically to whom you want to send. Then the value, gas price, and the gas. So the gas and gas price are like they vary. So it's completely another concept to explain, but this is the part of like a transaction fees. So once you want to, once you're ready with the transaction, then the most important part is the signing the transaction. So there are different algorithms are working behind this signed transaction. So you need your private key and the transaction which you just built. So based on this, you will get the signed transaction. And now using the Web3 method, send raw transaction, you'll be able to send the transaction. So it works asynchronously. So your transaction goes in the network, so it would be broadcasted and validated, and then you will get the confirmation later on. So this works asynchronously. Then the last part we will see is about how you inspect the existing blocks or the blocks which is just created. So your transaction was in the current block or the previous block. So you will get to know based on this web3.py. So you have this Ethereum object in the ETH object in the Web3. So you can get using the block numbers. Then you can get block, which is the latest one using the code get block latest. Then if you want to get the first 10 blocks, then you can write a for loop and use the get block method. And then if you want to access the specific transaction from a specific block, then you have another method, get transaction by block. So similarly, you can explore more details of Web3.py. There are a lot of examples given on this website. I will share it later in the chat. So for example, like I said, like you can talk to the smart contract also. So there is a method web3.eth.contract. So for that, you need some background in the smart contract. So smart contract has this like a standard ERC20. So there you have to write different functions, which are like you must implement them. So one of them is total supply. So this comes with ERC20, and there are some others like name, symbol, and balance of. So you can read each of these values individually. So yeah, so this was about the Web3.py, and I hope you'll be able to explore the examples on this website. And yeah, that's all from my side, and thank you. You can connect with me on LinkedIn, and yeah, thank you everyone for listening to me. And yeah, I hope you got some understanding of the blockchain and how to use Python for building the DApp. So thank you, everyone.
Oh, wonderful. Thank you so much. We didn't have so many questions come in, but we do have a few minutes to ask questions if anyone has any available. Suman did ask, she said, I'm new to blockchain and want to learn it. If you can provide the insight on how to start and what will be needed to learn, that would be a great help. If someone was really getting started, aside from coming to your talk and joining our blockchain track, is there anything specific for next steps that they could do to get started?
Yes, so I was at the same point year and a half before. So what I did was I came to the Women Who Code Blockchain. And I organized one series for beginners. So I really recommend you to join our Slack channel and go there and attend these 4 to 5 beginner blockchain series. That helped me and a lot of fellow colleagues to learn and get into the blockchain. So definitely I recommend you to start from there, because on the internet you can find so many things and it's very confusing. So I highly recommend you to go there and just attend these sessions, and you will get the basic understanding. And then we are also conducting a session for the developers who really want to understand each blockchain. So we are conducting the event in upcoming month, which are specifically for beginners and the developers. So you are free to join that too.
Okay, wonderful. Farah asked, what is the biggest challenge to get into blockchain development?
Yeah, so it depends, like there are different parts. So if you really want to get involved into the core blockchain development, or you want to get involved into the applications which are built on the blockchain, so these are like 2 different aspects, right? So if you want to just build an application based on the blockchain, then you are just how regularly you interact with the REST APIs. It will look like similar. But if you get into the core of the blockchain, then you need computer science background, and you need to understand how the distributed systems networking works. So these are like 2 different challenges you can face. So you need to decide like which way you want to go.
Do you have any tips for helping someone make that decision if you're really new? Is one better for a beginner, or more aligned with a certain profession or goal?
Yes, so if you are into the industry already working as a software engineer or software developer, and you already know some technologies like JavaScript, Java, Python, if you have even basic understanding of it, then you can start with decentralized applications, building decentralized applications. So you can start there and slowly understand this black box, how the blockchain works internally. Then slowly you can get into the core blockchain development. So I could recommend that path.
Okay. Someone made a comment earlier about blockchain, people having the opinion that it's the future of the internet. Do you think that's true?
Yes, it's true. Like I said in the diagram, I explained you about Web 3.0. So the backend is gonna change, and you will get to decide what you can do with your data. Right now, if you just go on any social media, you don't have any control over it. The companies which are saving your data have the control. For example, Facebook. So you don't have control over your data. But in the coming future, there is a concept called SSI, self-sovereign identity, that will help you to have control over your data. So I definitely feel it's the future. Yeah.
Okay, great. Farah asked a follow-up question. What languages does DApp use?
Okay, so there are different stacks. So what I hear is more about this React. So everybody wants to develop and DApp in React and JavaScript. And yeah, definitely I recommend you to start with that. Yeah. And you need to know JavaScript. So that's the important point. Yeah.
Okay, wonderful. Are there any other questions coming through? We have just a couple more minutes here. Is it necessary to know JavaScript, Manjiri?
Yeah, it would be good to have knowledge of JavaScript, because the Web3.py I explained is also, it came from Web3.js actually. So the Python came in the later part, and most of the codings which you see is happening in the Node.js. So I definitely recommend to have at least basic understanding of the modules in the JavaScript.
Okay, great. And Ashley asked, what skills are needed for blockchain applications? Not a developer. I think, do you mean, are there non-coding skills needed for building blockchain applications? Is that what you mean? Okay, great.
Okay, so non-coding skills, if I see, yeah, basically if you are in the financial domain, and there you need to make decisions on how the transactions flow. So right now you have a central ledger. So for example, here in Europe or here in Germany, so there is one company which handles all your credit card, debit card, all the transaction. It goes through them only. So yeah, it's like yeah. Okay, can you go back to the question?
Sure.
Again?
Yeah, so just wondering if there are
Non-technical, right? Yeah, for the non-technical.
Right, non-developer.
Yeah, so non-developer. So, for example, somebody is working in the business analyst, so they don't really code or do something. So if they want to move into the blockchain, so first is they understand the use cases, so where the blockchain can be used. So they should understand the requirement analysis part of the project, like why the blockchain could be useful. So understanding the basic feature of the blockchain you can start with if you are not completely into the technology yet. So this is how the non-developers could start because there are like two tracks in the career, right? So one is the analyst and the one is the developer. And if you think like more into like technical writing or something, I'm not really sure if without knowing the blockchain technology itself you can write anything technical.
Okay, great.
So, yeah.
And I'm always curious, what's next? What's in the future of blockchain? Is there anything exciting coming that we should look out for?
Right now, what I see, there are so many terminologies coming up, and definitely at Women Who Code Blockchain, we are going to organize the events where you will be able to get grasp on it, because every day there are new pop-ups like DAO, NFT, stable coin, this coin, that coin. So it's very confusing for the beginner to understand everything. Even me working for 1.5 years, it's like every day something new is coming up. So, and every company or the organization have different requirements. So everybody is working in different domains. So somebody is working in supply chain, somebody working in finances. So in the finances, if you see, there is a decentralized finance, DeFi. Then there is concept of DAO and and self-sovereign identity, like I said. So there are different use cases where people are working. So definitely it's gonna be quite exciting.
And for one of those use cases, you mentioned NFTs, and Jocelyn is curious, how are NFTs related to blockchain?
Okay, so suppose in the museum you have an artifact, okay, and that artifact is like worth of $1 million. So that is only one artifact, right, which is unique. So this NFT is gonna help you to make it unique, so nobody else can have the similar identity, or nobody can copy it. Suppose you have this artifact and somebody wants to copy it, but you will get the reward because they are gonna copy it or use it. So this is one of the aspect. And the other aspect is, for example, you have a house and you want to make it as an NFT artifact. So it is unique house, unique address, right? So it's gonna be like in the blockchain, if you see, it's gonna be yours in the first place. So when you want to transfer it and everything, it's gonna be visible in the blockchain. So it becomes more transparent and visible with the government's perspective, if you see. Yeah.
Okay. We have a few minutes left. Manjiri is a blockchain expert, but she is also been a developer for 8 years. She's getting her master's in tech industry. Do you have any questions for her just about being a developer or anything like that? I'm sure she would be happy to answer too.
Yeah, sure.
Any professional questions? Okay, well, thank you so much for your time. I think we had a birthday in the session, so if you're still here, happy birthday. I hope everybody has we have one more question. I'm gonna wrap up right after because we do have a few more minutes.
Okay.
How long did it take you to understand blockchain? And if other people need to drop off in the next session, I understand. But how long is the learning curve to understanding blockchain?
If the timeline just to get into the blockchain, I recommend you to spend minimum 6 months. Okay. So that's where you get the grasp, and then you can begin with which blockchain you want to work on, because the underlying concept is a distributed ledger technology. So you understand how the blockchain is one part. There are different part of DLT also, like Tangle is another one, which is like competing with the blockchain, and one from MIT also, Algorand it is called. So you need to understand the distributed ledger technology, and then inside it, how many are there, and inside the blockchain you have so many. So to making decision on which to work on is it's gonna take time, but just learning the basic concept will take you 5 to 6 months.
Okay, great. And Prachi followed up, and which one should they start on? I think we covered this a little bit with the 2 paths, but where the next step, if they were going to Google something today, getting started, what should they look for?
Yeah, getting started with Ethereum.
Getting started.
And we have one session upcoming by Austin Griffin. He's the best speaker I have ever heard from. So do attend our session. You will be quite benefited from that.
Okay, great.
We already had one session on Ethereum from him, and where he explained like how you can get started with scaffold. So that is definitely, I recommend you.
Wonderful. Well, you've given us a lot to think about. Thank you, everyone. We do have the contact here, so if you want to connect with Manjiri on LinkedIn, share her email is there as well. Thank you, everyone. Have a wonderful Connect Recharge experience, and we'll see you on the main stage and also hopefully in the networking sessions.
Thank you.
Thank you.
Bye.